Levostatin is structurally similar to the HMG, a substituent of the endogenous substrate of HMG CoA reductase. Levostatin is a prodrug that is activated in vivo via hydrolysis of the lactone ring to form the beta hydroxy acid. The hydrolyzed lactone ring mimics the tetrahedral intermediate produced by the reductase, allowing the agent to bind to HMG CoA reductase with 20,000 times greater affinity than its natural substrate. The bicyclic portion of levostatin binds to the coenzyme A portion of the active site. Now I'm going to show you the structural change of the levostatin. We have the inactive form right here. And as you can see, you have the ring right there, which is different than the active form over here. There is no ring present. So now I'm just going to go a little bit more in depth. The lovastatin is a cholesterol-lowering agent under the group of drugs categorized as statin. It is isolated from a strain of Aspergillus terris. Lovastatin is an inactive lactone which is hydrolyzed to the corresponding beta hydroxy acid form. Lovastatin serves as an inhibitor of 3-hydroxy-3-methylglutarol coenzyme A, which is also known as HMG-CoA reductase. HMG-CoA is a catalyst for the conversion of HMG-CoA to mevanolate, an important rate-limiting process for cholesterol biosynthesis. And then I'm just going to give you a little picture of it right here. Since lovastatin inhibits HMG-CoA reductase, which is a catalyst to HMG-CoA and cholesterol biosynthesis, it is responsible to hypothesize that the two molecules HMG-CoA and lovastatin share some common structural features. I'm going to show you another picture. This one right here, you have the arrow over there. The lactone group seen in the lovastatin picture, with the one that I just showed you, is hydrolyzed and open to form the terminal hydroxylic acid group on the beta hydroxy acid. The CoA thioester group of HMG-CoA is reduced to an alcohol by HMG-CoA reductase in an NADPH dependent reduction to form mevalonate in the isopentenyl pyrophosphate formation process. The group that is similar in property to the thioester group on HMG-CoA is the newly formed terminal hydroxylic acid group. Since lovastatin is inactive in its lactone form, it is reasonable to suggest that the HMG-CoA reductase will reduce the beta hydroxy acid at its carboxylic acid end in the similar fashion to the thioester reduction. Research has suggested that HMG-CoA group binds to the active site of its reductase, HMG-CoA reductase, with NADH as the other cofactor. HMG-CoA is bound predominantly by the large domain of one monomer and NADH by the small domain of the symmetry-related monomer. And I have another picture of you for you right there. So this picture is one of the monomers of HMG-CoA reductase. The arrows that were on it point at the active sites at the junction of the top of the stem of the T-shaped monomer. This active sites are large and small domains on the dimer. The HMG-CoA is bound by the large domain in an in an extended form that stretches across the active site cavity. The NADH is bound to a small domain of the symmetry-related monomer of HMG-CoA reductase. In these binding configurations, the nicotinamide ring of the NADH is a position within 3.5 angstrom adjacent to the scissile bond of HMG-CoA. Thus, dimerization is a prerequisite for the active sites in HMG-CoA reductase. This reaction is analogous to the two successive reactions of an aldehyde dehydrogenase and an alcohol dehydrogenase. Both are done by HMG-CoA reductase. A competitive inhibitor acts by reducing the concentration to free enzyme available for substrate binding and reduces the amount of product. In this particular case, lovastatin in its beta hydroxide form acts as a competitive inhibitor and reduces the binding of HMG-CoA to HMG-CoA reductase, thus reduces the amount of cholesterol product. The suggested hypothesis is that the structure of the lovastatin has the ability to bind to HMG-CoA reductase's large domain in a way similar to that of HMG-CoA. Also, instead of the thioester group of HMG-CoA binding next to the NADH, it is the terminal carboxylic acid group on the beta hydroxy acid that will interact with the NADH in its competitive inhibiting process. And I hope that this helps.